Should we go ahead and start?
Yep.
Good morning, good afternoon, and good evening, colleagues, wherever you are across the Americas and in the world. I am Andrea Seeley, and I am chair of the Pan American Regional Node of the World Meteorological Organization's Sand and Dust Storm Warning, Advisory, and Assessment System, SDS-WAS. And I'm also a meteorologist at the Caribbean Institute for Meteorology and Hydrology, CIMH, located in Barbados, which hosts the SDS-WAS Regional Center for the Americas. I am extending a warm welcome to those of you joining this webinar to recognize the International Day of Combating Sand and Dust Storms. This event is co-hosted by the WMO SDS-WAS Regional Center for the Americas and the Dust Alliance for North America, DANA. Recognizing that sand and dust storms and their negative impacts at different scales are issues of international concern, the United Nations General Assembly proclaimed the 12th of July as the International Day of Combating Sand and Dust Storms. This represents a move towards enhancing awareness of SDS and mobilizing the political will and resources needed to address SDS-related issues, which present a serious challenge to the achievement of the UN Sustainable Development Goals. The transboundary nature of sand and dust storms and their impacts makes it extremely important to have global, regional, and national coordination and cooperation, considering that there is increasing frequency and severity of sand and dust storms and their impacts. In the Americas and beyond, the impacts of SDS range from health and safety, including various illnesses, animal diseases, transportation safety, food and water contamination, to other impacts such as reduced solar energy. Before I turn you over to my co-moderator, Scott Van Pelt, who will introduce himself and also welcome you with some remarks, I want you to take in as much as possible and feel free to engage speakers and colleagues as much as possible over the next couple hours. Over to you, Scott.
Okay, thank you, Andrea. I'm Scott Van Pelt. I'm a research soil scientist for the U.S. Department of Agriculture, and I'm also currently the president of the Dust Alliance for North America. Dust Alliance, or DANA as we shorten it in the acronym, is a group of hundreds of dust scientists, practitioners, and people that just have an interest in dust in the atmosphere. The goal of DANA is to get the science out of the journals and into the hands of people that can use the information to improve the lives of the people in this hemisphere and beyond. Even though we have a local focus, we also have a global mission. And to that end, we are making some headway. And I'm not saying that DANA is making some headway. I think the dust community as a whole is. I live in the country, and so I have a short walk to my mailbox. And last week, I walked up to get my mail and found the August issue of Consumer Reports, and it talks about the danger in your dust, including pesticides, PFAs, and heavy metals. So once it gets into popular press, we know that people are going to start paying attention. And so even though some of us have led the way, I have a feeling that there's a lot more work to be done. And with that in mind, I just want to wish everybody and join Andrea in welcoming you. And I will turn it over to, we have a welcome from the WMO, from Daniel, and from Susan, or from Sarah, excuse me.
Hello, I'm Daniel Tong. I'm the chair of WMO Sand and Dust Storm Research Program.
Hello, my name is Sarah Bazard. I'm the focal point for sand and dust storms at WMO. Today, we are all together to celebrate the International Day for Combating Sand and Dust Storms. Sand and dust storms are a weather environmental phenomena associated with strong winds that lift large amounts of sand and dust from dry soils into the atmosphere. transporting particles across vast distances. Sun and dust storms have become a serious global concern due to their significant effects on human health, livestock, agriculture, and socioeconomic well-being. Recognizing this, in 2023, the United Nations General Assembly designated July 12 as the International Day for Combating Sun and Dust Storms.
This important day highlights the needs for global and regional cooperation to manage and mitigate the effects of those storms, which pose serious hazards to our communities at local, regional, and global scales. The UN resolution acknowledges that the sand and dust storms negatively impact the achievement of 11 out of the 17 Sustainable Development Goals. It also recognizes that climate change is a potential contributor to future wind erosion, increase the risk of such storms to our communities.
To address this important issue, the World Meteorological Organization, WMO, established the research program on sun and dust storms called SDS-WOS in 2007. This system enhanced countries' ability to provide timely and high-quality forecast, observations, and knowledge of sun and dust storms through an international partnership with experts, providers, and users.
It facilitates the transfer of technology from research to society, supporting the development of sustainable solutions for our public and private sectors. At present, there are 4 WMO regional centers supporting the development of such dust services and early warning systems in Barcelona, Beijing, Barbados, and Jeddah. Despite those efforts, effective mitigation of the negative effects of dust storms requires more work, including better integration of quantitative information into policies and practices.
Coordinated efforts at regional and global levels are essential for designing and implementing mitigation and adaptation plans to combat sun and dust storms. Join us in recognizing and addressing this critical global issue.
Thank you very much for organizing this event.
And happy Dust Day to all of you.
Hi, this is Daniel Tong again, and happy Dust Day to everyone. Thank you for joining us, and thanks a lot to Andrea, the Pan America Center, and Dana to hosting this wonderful event. I'm going to give a brief introduction of what the SDS-WOS is, and just offer some opportunity in that how we can work together as a community under the umbrella of global cooperation. So I'm an associate professor at George Mason University, but I also wear the hood of the chair of this WMO dust program. The SDS-WOS stands for Sand and Dust Storms Warning Advisory and Assessment System. It's governed by a global steering committee, including 10 members from around the world. And Sarah Bassett is the scientific officer and the focal point of Sand and Dust Storm at WMO. So the mission of SDS-WOS is to build international coordination for sand and dust storm observation and prediction research, and also translate to services. So we have to identify and assess the impact of sand and dust storms on our society. We want to promote the use of current available SDS products, and we're trying to help regions to build the capacities so that they can access to the most advanced technology and data products to use for the local decision process. So in that sense, we are also working very hard trying to help out with the information dissemination and raise the public awareness. As I mentioned, we have 4 centers. This is the Pan America Center hosted by Barbados. Andrea is the regional center chair. We have one in Barcelona, that's in the North America, Middle East, and Europe Center, hosted by Barcelona Supercomputer Center. And we have another one in Asia, hosted in Beijing, the chair rotated between Beijing, Japan, China, Japan, and Korea. And currently, the chair is Takashi Maki. And then we also have a new one in the Middle East. It's called Gulf Cooperation Council region. Juman is the chair right now. So this is an overview of SDS activities. Routinely, we participate all the UN activities related to sand and dust storm on behalf of WMO. That's including UNCCD, which is the United Nations Coalition for Combating Desertification. And we also interact a lot with the WHO to provide the data to support the health studies and air quality guidance. WMO also published the airborne dust bulletin, which I will mention a little bit later. And we also make a 5-year science implementation plan for WMO. And then the last one, routine work, is also capacity building I mentioned earlier. In recent years, SDS was launched a few new initiatives. I think that may be of interest to this group. One of the major highlights in the coming years, we're trying to build operational dust centers. There are some countries are lucky enough to have their own dust forecast, but that's not the luxury every country will enjoy. So we are trying to coordinate the resources and then come up with regional centers to cover the entire world. And we are going to develop an ensemble dust reanalysis to have a history of what's going on in the past regarding sand and dust storms. We are mapping global dust vulnerability to see how the sand and dust storms impact individual communities. And we also provide a dust product for the health community, such as the Lancet countdown. And then many applications for education, renewable energy, and so on. So I want to mention this is a great work led by Andrea. That's we just came out today. We released the number 8 issue of the WMO Airborne Dust Bulletin. And this covered a lot of information regarding the long-term dust trend, major events in the past, and also research highlights and capacity building. So if you have any topic related to this WMO bulletin, I encourage you to submit that content to us so we can help promote your research on a global platform. And they're going to have they just had actually a press release today with WMO Secretary General today. And finally, I just want to end this Dana and Pan American Center joint event is a part of a big wave of the global dusty webinars today. We started from yesterday in the Middle East, and then we come this morning at 4 a.m. For the first event, and then now it's our last event. But I think this is a wonderful part of this global campaign. And thank you all very much for helping raising the public awareness of sand and dust storms. With that, I will yield the mic back to you, Scott. Corinne.
All right. Well, thank you so much, Danielle, and thank you for the blessing, Andrea and Scott. I'm Corinne Arden-Dreyer. I'm currently an associate professor at Texas Tech University, but I'm the elected chair for Dana. And I'm happy to start our second portion and most important of today. We have invited talks from 8 speakers. Each one of them will have 10 minutes. And at the end, we're going to have a town hall with time for questions. We gave a very big challenge for each of our speakers, so I'm sure they're all gonna put their effort into it. Our first speaker is Tom Gill, and Tom, feel free to already share your screen. Tom is gonna talk about emerging issue and challenges in combating sand and dust storm. We're waiting for the slides. All right. Tom, the stage is yours.
Thank you very much, Corinne. I am hoping everyone can see my screen. Thank you so much for the invitation. Happy Dust Day, everybody. I'm going to start us off just by going quickly through what I see as some of the most important emerging challenges and issues, and I guess you could say wicked problems, especially in the Pan American region, in combating sand and dust storms. And by doing so, I'm going to be literally ripping a lot of things from the recent headlines. I didn't have to think too far and back into too many days' news to find issues related to dust that provide issues and challenges in the combat against sand and dust storms. So this was just from earlier this week. I live in El Paso, Texas, USA, and not far from me, down the highway in New Mexico, we had some serious dust storms earlier this week. And this was an alert from the National Weather Service in El Paso about the severity of the dust on Interstate 10, one of the major transcontinental highways in the United States, near Lordsburg, New Mexico. These sudden clouds of dust crossing highways, especially like Interstate 10 at Lordsburg, are a continuing problem. And unfortunately, this one particular spot in New Mexico, Lordsburg, despite all of the signs and warnings, has led to dozens of fatalities in dust-related highway crashes in recent years. And unfortunately, this is not just a problem in the southwestern deserts of North America. It's also occurring in other areas, such as this event, which made, I think, the world news more than a year ago. In Illinois, in the Farm Belt of the central United States, a blinding dust storm on another highway killed 8 people in crashes. And here you see part of the problem. The dust clouds are low to the ground. They're difficult to sense. They're difficult to see from a distance. And they're very difficult to forecast and warn for. This is a great challenge. Research that a number of us have worked on have shown that dust-related highway crashes kill as many people every year as many other severe weather hazards in the United States, at least, such as winter storms. Tens of millions of dollars has been spent on mitigating these dust-related highway hazards, and their total economic impact is clearly much greater. But it's not just on the ground, it's also in the air. Again, this was just earlier this week in the news, a new study showing that the increasing amount of desert dust ingested by aircraft taking off and landing in dusty regions is increasing engine wear and increasing hazard to aviation, especially when aircraft are preparing for landing or they are put in holding patterns in dusty environments. It is creating a serious potential hazard to safety of aviation and a greater than realized expense. Alternative sources of energy, especially wind and solar, are increasing in importance. But these are generally deployed in arid areas where there's a lot of dust and sandstorms. The soiling impacts on solar energy production are well studied, and their costs account for hundreds of millions, if not billions per dollar. Effects on wind turbines are not as well established, but a lot of wind turbines are being installed in dusty, sandy areas, such as the Texas Panhandle we see here. And they certainly have a growing impact on wind power systems. Scott showed this headline from the latest Consumer Reports magazine, "The Danger in Your Dust." Now, the Consumer Reports article was about indoor dust, but of course, we're also concerned about the dangers in outdoor dust. PFAS, or the so-called forever chemicals, endocrine disruptors, viruses such as potentially COVID. But here's something else out of the recent headlines that made me think. You may have seen this article. These beautiful painted lady butterflies have been shown to be able to fly, weakened but alive, 2,600 miles across the Atlantic Ocean to northern South America and survive along the Saharan air layer that carries the dust from Africa to the Americas. Well, it's wonderful and beautiful that these beautiful butterflies can travel the Saharan air layer along with the dust. But what if it wasn't a beautiful butterfly? What if it was some type of insect that was a serious agricultural pest? What if it was something that carried pathogens? We have to think about that. We do know that pathogens such as the soil-borne pathogen coccidioides, which causes the emerging infectious disease valley fever, is caused by human inhalation and exposure to airborne soil. We'll be hearing later today from Morgan Goris about that. This is a growing, emerging infectious disease in the Americas. Another growing topic of importance in the environment is our realization that microplastics are spreading everywhere. And by spreading, and we don't know what effects they're going to be having on the environment, on ecosystems, and on humans, but we know they're having significant effects. And that includes microplastics getting into the air and flying along with the dust particles. What effects are they having through their atmospheric transport? Maybe even on the climate system, as well as health and ecosystem effects. This study just recently came out earlier this year, and it showed, in fact, that plastic dust, you could say, tiny microplastic particles, are more easily emitted into the atmosphere and preferentially suspended into the air more easily than mineral dust. So that this plastic dust may be preferentially getting into our air, maybe even more easily than mineral and soil dust. Back in the desert, we have emerging sources of dust in the Arctic. As the Arctic is warming fast, glaciers are melted, drainage patterns are being changed, and we have emerging dust sources in the Arctic, such as Kluane Lake in Canada, and in the areas where glacier flats have been exposed in Alaska are producing a lot of glacial-related dust that's getting into our atmosphere. And we wonder, what effects is that having on the global system, as well as there in these high latitude environments? Down in the deserts, as drought increases and the fight for water supply increases, desert lakes are drying out and turning into major sources of dust. We'll be hearing more about that next from Kevin Perry. In the mountains of Western North America, dust is getting on the snow and accelerating the snowmelt and causing accelerated impacts and changes to the hydrological cycle. While all this is happening, the ways that we look at dust is changing. Some of the satellite-borne sensors that we've relied on for decades are now reaching the end of their mission, such as MODIS, while new satellite sensors, such as GOES-U, which was just in the news last week because it obtained geostationary orbit and officially became GOES-19, and the new TEMPO mission have great promise for changing the way that we model and forecast and combat dust storms. So these are all some of the challenges and opportunities that we are facing. We'll be hearing a lot more about them today from the rest of our speakers. Thank you for the opportunity to set the stage with some of these key issues, and happy Dust Day to everyone. Thank you very much.
Thank you very much, Tom. That was great introduction to the session. Our next speaker is Professor Kevin Perry, and Kevin will talk about framing the problem, cause and consequences of shrinking Great Salt Lake.
Okay, thank you so much for having me and doing a great introduction, Tom. Hopefully I can do a good job of bringing this home for an issue that's actually happening here in Utah, in the United States, with regards to the shrinking Great Salt Lake. Great Salt Lake in the western United States is really one of the most important ecological oases in the western U.S. It annually hosts more than 13 million birds on migration pathways. It's a hemispherically important bird migration pathway, and it's also a host to many different types of wildlife. And it's also great economic and cultural significance in the state of Utah, producing more than $1.5 billion in revenue to the state of Utah. And it's been used for thousands of years by the indigenous populations as well. If we look at Great Salt Lake over time, here's a time lapse from the Google Earth engine starting in 1984 and proceeding through 2020. And you'll see that there's been a massive change in the surface area of the lake, and it is a now exposed significant playa. And along the shores of this lake live 2.5 million residents that literally live right on the doorstep of the lake itself. Here is a MODIS image from November 21st of 2022, when the lake reached its lowest current elevation. And at this point, there's more than 800 square miles of exposed playa. And that playa produces dust storms that then inundate the surrounding communities periodically. And just to put 800 square miles into perspective, it's about the same surface area as the island of Maui in Hawaii, or 60% of the state of Rhode Island. And I love political cartoons. Clearly something is amiss with regards to the hydrology of Great Salt Lake. I happen to be part of a Great Salt Lake strike team that was empowered by the state legislature in Utah to try and understand the causes and consequences of the shrinking of Great Salt Lake. And there are really only 3 potential causes, being climate change, drought, and water diversion. And our strike team basically determined that changes in temperature leading to increases in evaporation are responsible for about 10% of the cumulative water loss over the last 30 years of Great Salt Lake. The ongoing mega drought is responsible for about another quarter. But for this particular lake, water diversion is responsible for about 2/3 of the water depletion from this lake over the last 35 years. So what are we diverting that water for? Well, 2/3 of the water diversions are associated with agriculture, 10% are for cities, 10% is for industry, and then there's about another 8% which is going for mineral extraction. And the largest user of water for agriculture in our state is for alfalfa and hay. We grow very high quality alfalfa and hay that's in demand worldwide, and some of that alfalfa is actually shipped to China and Saudi Arabia. So what are the consequences of a shrinking Great Salt Lake? And I'm going to put this in terms of tipping points. So as a dust scientist, an atmospheric scientist at the University of Utah, living on the shores of Great Salt Lake, I noticed dust plumes coming off of Great Salt Lake as early as 2010. And subsequently, as the lake got lower and lower, recreation opportunities on the lake were becoming more and more limited. And as the lake continued to shrink, even the industrial extraction of minerals was under threat as recently as 2023. But the big news, and the one that has garnered a lot of attention, is as the lake has been shrinking, the salinity has been increasing, and there's a salinity crisis in Great Salt Lake, which basically could lead to entire ecological collapse. And that was essentially kind of on the imminent. We're on the doorstep of that. And within 5 years, if we don't do major conservation efforts to deliver water to the lake, we could be a situation where the lake loses its ability to support the millions of birds that come visit every year. Here's an example of a dust storm that comes through Great Salt Lake. This is from the University of Utah. The Great Salt Lake is to the right. We have a cold front that is going to move and bring the dust into the community of Salt Lake City, reducing visibilities to less than 1.5 miles, causing air quality PM10 and PM2.5 concentrations to rise to unhealthy levels. So where is the dust coming from? Well, I participated in led a study to identify the hot spots for where the dust is originating on Great Salt Lake. All 4 quadrants of Great Salt Lake are dust hotspot regions. And with these cold fronts, we have strong winds from the south before the cold front passes, and then strong winds from the north. And so what it does is it takes this dust and moves it in different directions depending upon where it's at in the storm. And so I like to basically say that all 2.5 million residents along the Wasatch Front Mountains are essentially downwind from the lake at some point during these storms. So what are we worried about? Well, one is particulate matter exposure. High PM10 and PM2.5 concentrations can lead to violations of the National Ambient Air Quality Standards. And the science is well established that exposure to these particles, regardless of what they're made out of, can lead to a wide variety of lung impairment and can lead to heart attacks, strokes, and even premature death. But there are also long-term chronic exposures that we worry about. And like many saline lakes in the Western US, there are very high concentrations of arsenic in the soil, much higher than the regional screening levels established by the EPA. In fact, more than an order of magnitude greater than the EPA regional screening levels. And chronic exposure to Great Salt Lake dust could lead to a variety of cancers, including lung cancer, skin cancer, and bladder cancer. As Tom said, dust on snow can darken the snow. Here's an image of a snow pit from the Wasatch Mountains. You can see the layers of the snow with dust in them, and that accelerates the snow melt. A study done by Mackenzie Skiles here at the University of Utah showed that the addition of dust to the snowpack can reduce the time required to melt the snowpack by up to 3 weeks in Salt Lake. Recreation loss. The Great Salt Lake has a long history of boating, and the state has spent millions of dollars trying to dredge to keep the marinas open. But this is what some of the marinas look like today. So very little boating going on in Great Salt Lake right now because of a lack of access to the water for the boats. In terms of industry, the mineral extraction industries are pulling out different types of salt. They're pulling out potash, and they're starting to pull out lithium. But they need canals to bring the water to their facilities. And those canals, as the lake shrinks, are in danger of no longer reaching the lake. And that poses a risk of about $1.3 billion annually. The shrinkage of Great Salt Lake also has an impact on lake effect snow, which impacts the local ski areas. Lake effect snow contributes about 5 to 10% of the water to the Wasatch Mountains, but it crucially provides snow during the months when they're trying to get the ski season started. And the risk analysis there is about $2.8 million per inch of snow. The Great Salt Lake also hosts a very robust brine shrimp industry that produces about 45% of the world's total. The brine shrimp are used in the aquaculture for feeding crustaceans around the world. And the risk to that, as the salinity increases, the salinity can get too high for the brine shrimp, can risk about $67 million annually. And of course, the brine shrimp and the brine flies are the base of the food chain, essentially, at Great Salt Lake. And as the salinity goes up, you're at risk from actually losing these very important sources of food for the birds. that are going through. Here's just an example. The video is kind of choppy, but brine flies out in Great Salt Lake. And just to put things into perspective, wonderful bird habitat juxtaposed with exposed lake bed. During a dust event, I might add. And there are reasons for cautious optimism. For Great Salt Lake, the shrinkage is primarily driven by overconsumption, which means that we can change how we actually use our water. The citizens of Utah are really concerned about this and have been very vocal. The state legislature has undergone massive changes to our water law over the last 3 years, and they've invested more than $1 billion in water conservation efforts. And they've also put in a whole bunch of infrastructure to track these water savings to make sure that that water is actually shepherded to the lake. But we do have ongoing concerns. The mega drought is likely to continue for another 10 years. Utah's population is booming, which puts more pressure on our water supplies. And of course, climate change will continue to increase our evaporation. And I'll leave it at that with my 10 minutes.
Thank you so much, Kevin. That was super interesting. We're going to move to our next speaker. Our next speaker is Daniel Buccizo. I'm sorry if I'm murdering your last name. Daniel, feel free to start sharing your screen. Daniel will talk about dust of anthropogenic origin in certain South America.
Hello, everyone. Thank you for the invitation. I'm going to speak about dust of anthropogenic origin in South America. If we analyze the dust sources in South America, I made a very fast, a very rush review. There are some dust coming from Sahara. There are some articles on this from many people all around the world. And there are some dust coming from the continent, mainly from Altiplano, the high plains from northern Argentina, Chile, and ephemeral lake called Mar Chiquita. All this joined in the air, and it's coming from north to south. There are some articles on this from Gallero and other people from Argentina. And there is another source from Patagonia dust that is moving mostly from west to east. There are surely another dust sources within the continent, but I didn't want to speak about this. I want to show you what we are doing in this region. This is our study region. This is mostly a semi-arid region. And the soils develop on this region unless that means that is an Aeolian sediment, and soils are very easily eroded here. And the dust, of course, is produced by wind erosion of soils, and dust moves mostly regionally. The dust is moving from several parts. In the south of this region is mostly from west to east. That is common in the Patagonia region. Center of this region, winds are moving mostly from north to south. These are the more erodible winds in the region. Sometimes we have wind erosion from the south and eventually from west to east. I want to show you some pictures on what's happening in this region. This is in the center of the semi-arid strip. This is Cordoba province. Here we have a dust plume produced by erosion of agricultural soils that were under peanut production. Peanuts are a big problem in this region. There are a lot of erosion events, many car accidents, and some people dead every year. This is some pictures, some there are some pictures of the center of this strip, semi-arid strip, where we are working in Santa Rosa City. This is a picture of erosion of agricultural soils. Agricultural soils are a very important source of dust in this region. Every spring, we have some important event. This event reaches some urban cities like Santa Rosa, for example. This is another picture. But we have also some dust plumes produced by erosion of burned forests. Fires in natural forests are very common in this region. We have many hectares each year that are burned. And in this occasion, we had a very big plume coming through Santa Rosa City. This dust plume was composed mainly by ashes, of course. And we go to the south of the strip, and we can see in this satellite imaging a very important dust plume produced by erosion of agricultural soils. In this case, the soils are used for wheat production. This is the only crop we can grow here because of climatic conditions and soils constraints. What happened here is that the farmers went to the field, they plowed the soils, and at the other day there was a very big storm, wind storm from the west, and these were the consequences. Dust blowing from the continent to the ocean. And this is how this storm were seen from the surface. Of course, in this case, we had some car accidents too, and some people were dead. So with this picture, you can imagine that our concerns about dust emission in the semi-arid Argentina are the study of the relationships between soil type and dust emission, mainly texture, different texture soils. We are studying management and dust emission, how management condition makes different dust emissions. And what we are studying is mainly agriculture, feedlots. Feedlots is a very important production system in the region, and a very large amount of cattle produces dust emissions, very local effects, but very important for human health. And of course, we are studying dust emission from burned natural forests. We also are measuring dust composition, mainly herbicides. The dust is coming from agricultural soils, and then herbicides may be composing the dust. We are analyzing also organic compounds and inorganic compounds. What are we using to measure PM10 dust? Some sensors like Canamax or Green. We are using in wind tunnels and in the field. We have our own devices. There are some developments made by Mariano Mendes in this case. This is the Easy Dust Generator. This is the name it received, the device. This is very simple. It's a plastic jar that rotates. The soil sample is put in this jar, and the rotation makes the dust to be emitted and is measured with the dust monitor, in this case, a Canamax. And in the right, sorry, this is a modification of this Easy Dust Generator that's composed also by a plastic jar that rotates, but in this case, the dust is sorbed by ionic, but by an ionic surface, and then we can sample this, collect this with a brush, and we can collect up to 2 or 3 grams, and we use the samples to make some determinations. Some results very fast. We measured in the field. This is a part of a PhD thesis from Fernando Avesilla. He measured in the field what happened in the sandy loam soil and in a sandy soil. How was the PM10 emission? And you can see that there is a tendency to increase with wind velocities. That was to be expected. But there is a big difference between the emission of both soils. You can see the red arrow is the 50 micrograms per cubic meter of PM10. That is in this section of the graphic, and is outside in the sandy soil. It means that the emission of the sandy loam soil is much higher than in the sandy soil. Another result that we have found is a relationship between the potential PM10 emissions and some soil properties. In this case, there is a very good relationship, even when the number of samples is not very high, between PM10 and the quotient between silt and organic matter. These relationships, so these variables, these parameters are somehow different from that proposed by Webs, for example, that considers only silt. We have made some microscope evaluations. In this case, 2 sandy soils, the PM10 emitted from both soils, a sandy soil and a sandy loam soil. And you can see in the sandy soil, there are mostly individual quartz grains, many fresh organic matter rests. You can see this kind of pipes, of tubes. These are organic rests, and there are not aggregates. In the case of the sandy loam below, there are a lot of aggregates, mostly composed by organic matter, and mostly no fresh organic rest. We also analyzed in samples, in PM10 samples, the glyphosate contents. In this case, results from Mariano Mendez. We compare 3 management systems. Harvest crop, the system receives each year glyphosate and other herbicides too, but not these 2. Management system, forest crop, and permanent grasses. And we are a little bit surprised because the content in this both systems were really very high. We don't know if this glyphosate and AMPA is coming from the application in this system or remains in the soil from other rotations stages of the soil. What we want to do in the future, we want to maintain the same research lines, measure dust emission amounts from agriculture, feedlots, and burn natural forests. We want to analyze dust composition with another herbicides and another pesticides in general, another organic compounds and inorganic compounds. But we want to start some new lines. For example, we need to differentiate between external and local inputs, because there is some amount of that coming from another sources other than winter soils. And we're starting some studies on the effect of dust on soil properties, mainly how the dust affects the evolution of the soil. We have some publication already on that. And very important for our region is the relationship between dust amounts and composition and human health. There is a big concern in Argentina right now on which is the effect of dust coming from wind-eroded soils on human health. I want to finish making some acknowledgement to our research team. In this case, Mariano Méndez, Esteban Panebianco, Laura de Oro, Fernando Avesilla, Antonella Iturri, and Juan Cruz Colasso. They are former students from myself, and they are now independent researchers. And I want to mention also our German colleagues who helped us in many determinations, Roger Funk and Michael Sommer. That's it. Thank you.
Thank you so much, Danielle. I will ask you to stop sharing your screen. So our next speaker, John Haynes, will be able to give our next talk, which is overview of the NASA Health and Air Quality Application Program. John, we can see your slide. The stage is yours.
Wonderful. Thank you so much, Corinne. Thanks so much for the introduction and the invitation to chat with you today. As was mentioned, I'm John Haynes. I serve as Program Manager of Health and Air Quality Applications, part of Earth Action at NASA headquarters in Washington, D.C. And today I wanted to give an overview of our Health and Air Quality Applications program and its intersection with dust and sandstorms. And so for us in NASA Earth Science, our story really begins here. And here is several hundred to several thousand kilometers above our head in Earth's orbit, with our constellation of over 20 satellites and sensors that are continuously monitoring Earth's weather, climate, and environment for research and applications purposes. This constellation of Earth-observing sensors and satellites, including several sensors on board the continuously crewed International Space Station, represents the largest civilian Earth-observing constellation the world has ever known. And it would not be possible, of course, without our partners, both in the United States, such as the United States Geological Survey and the National Oceanic and Atmospheric Administration, as well as internationally, with partners including the European Space Agency, the Japanese Space Agency, the Canadian Space Agency, just to name a few. So when you're taking a look at this constellation of our Earth-observing satellites, the ones in the cooler colors, the greens and the blues, are the ones currently on orbit. The ones in the yellows, oranges, and purples are the ones we plan to launch from now through the end of the decade to keep this a very robust Earth-observing constellation. Every day, we download approximately 25 terabytes of data from these satellites on the Earth system and how it is changing. Of course, many of those are very important to dust source locations and to dust and sandstorm monitoring. For example, information we get from our MODIS sensors on board Terra and Aqua, information we get from our VIRS sensors on board NPP and the NOAA JPSS system, as well as information about dust source points from Landsat, which is in conjunction with U.S. Geological Survey. So all of these types of observations we get, including those on aerosols, are critical for health and air quality applications. These are just a few of the critical data sets that we get from our unique vantage point in space. And the good news is all this data is free. It's all open access to anyone across the globe, all available at earthdata.nasa.gov. I wanted to highlight one particular sensor that maybe is not as well known as Landsat and MODIS and our others. It is a sensor on board the International Space Station known as EMIT, the Earth Surface Mineral Dust Source Investigation. In 2023, EMIT produced its first global maps of 3 minerals, as you see there, hematite, goethite, and kaolinite, in Earth's dry regions using the data from the year ending in last November. The mission has collected billions of measurements of these 3 minerals and 7 others that may affect climate when lofted into the air as dust storms. And I will mention that this sensor is a project of the NASA Jet Propulsion Laboratory in conjunction with Caltech. Now, where I sit in the Earth Action Program, our job is to enable people and organizations to apply insights from Earth science to benefit the economy, health, quality of life, and environment. And we do this through partnerships with end users and stakeholders across the United States and across the globe. As particularly in health and air quality, we work with these stakeholders in order for them to access and utilize the treasure trove of Earth observations that we have downloaded from orbit in order to make better management policy and forecasting decisions related to health and air quality. Our three kind of watchwords are scalability. We may be doing pilot or demonstration projects in one region of the country or the world, but we want those to be scalable to other areas. We want to build bridges not only to new communities, but internally at NASA to our basic research and technology parts of the Earth Science Division, while always being focused on user-centric solutions, always looking at what the challenges and the problems that our end users are facing and how Earth observations can be brought to bear on those problems. So in the Health and Air Quality Program, which I've had the pleasure of leading now for about 20 years, the main reason that we have this program is because of the impact of climate change on human health. Because when you think of the climate crisis, it really is a health crisis. And this infographic from the United States Centers for Disease Control and Prevention kind of says it all. Rising temperatures, more extreme weather events, rising sea levels while increasing CO2 levels in our atmosphere are driving so many changes in our Earth system. And all of these changes have impacts on human health. And of course, we know that issues with drought, for example, and extreme heat, those are leading to increases in dust and sandstorms across the globe, which of course impacts human health, impacts our respiratory system, impacts our cardiovascular system. This World Health Organization infographic kind of speaks to that air pollution really is the silent killer. The WHO estimates that every year around 7 million deaths, excess deaths worldwide, are due to exposure from both outdoor and household air pollution. So within my program, we support the use of Earth observations in air quality management and public health, particularly regarding infectious disease and environmental health issues, toxic and pathogenic exposures and health-related hazards, the implementation of air quality standards, policies, and regulations, as well as the effects of climate change on health and air quality. And throughout all of the projects in our portfolio, which now number over 30 projects active in our portfolio, the largest it's ever been, we always want to be sure that we're looking at these through the lens of One Health. The One Health theory being, or paradigm really, being that human health is inextricably connected to the health of animals and to our shared environment. To understand global health, you have to look at the Earth as a holistic system. You can see some of our major partners at the bottom. I'm certainly not going to mention them all, but we have partners all the way from in the United States, the state and local level, to federal agencies, all the way up to international organizations, of course, including PAHO. We've had several projects over the past few years investigating issues related to dust and sandstorms. I'm not going to get into the ones we've heavily supported and worked with Daniel Tong at George Mason University on many dust storm related projects. Not going to discuss those because I know he follows me, didn't want to steal his thunder. But I'm going to highlight this one instead. This is a project that was in cooperation with the University of Puerto Rico Medical Sciences Campus, as well as the United States Environmental Protection Agency and the National Oceanic and Atmospheric Administration's Weather Service Office in San Juan, Puerto Rico, on forecasting poor air quality events in the Caribbean, particularly related to Saharan dust. As we know, Saharan dust storms cross the Caribbean with regularity, adversely impacting air quality and human health. We were able to develop partnerships throughout the Commonwealth of Puerto Rico to build an operational air quality forecasting tool to inform policy decisions, educate the public on health risks related to dust storms, and safeguard health. Now, this operational air quality forecasting tool, developed in cooperation with NOAA, is live on the NOAA CARICOOS website. That stands for the Caribbean Cooperative Ocean Observing System. So if you go to the NOAA CARICOOS website, you're able to click on the aerosols tab, and you will see 72-hour forecasts of air quality across the Commonwealth of Puerto Rico. So that informs, of course, people to be able to make better decisions, not only the public, but also healthcare providers and forecasters. It heavily utilizes information on dust concentration and aerosol optical depth from several of our NASA satellites, including the VIIR sensor on board SUMI NPP. And what you're looking at here is it was very fortuitous. This system went into beta operations in mid-June 2020. And that was right before that Godzilla dust storm, the worst Saharan dust storm in a half century, impacted the island of Puerto Rico. You see the images of the San Juan skyline from June 20th versus just a few days later when it's totally obscured. And this was our NASA data from NPPVers of the aerosol optical depth during that Godzilla dust storm. I would be remiss not to invite all of you to join the Group on Earth Observations Health Community of Practice. I am very proud to co-chair this community of practice along with a colleague of mine from the U.S. National Oceanic and Atmospheric Administration, Julie Treton. The GeoHealth Community of Practice serves as a global network of governments, organizations, and observers who are looking to use Earth observation data to improve health decision-making at all levels. We have regular meetings, virtually, of course, about twice a month. We now have over 400 people worldwide as part of this health community of practice, and they have self-organized themselves into working groups to help this cooperation and collaboration on different facets of the health issues, including on air quality. It's not hard to join at all. It's open to everybody. If you just scan the QR code and go to our website and sign up for our listserv, you're in. And we would love to see more of you at our meetings in the future. And looking forward to the future, these are 3 satellites that are either have recently been launched or going to be launched very shortly that are going to have a large impact on air quality, including on aerosols. It was mentioned earlier, I believe by Daniel, about TEMPO. TEMPO is a revolutionary satellite. It is our first air quality satellite at NASA that is in geostationary orbit. So it is monitoring air quality across the greater North America region, hour by hour in the daylight, at an unprecedented spatial scale, down to neighborhood resolution. It's collecting information on a wide variety of pollutants, and aerosol products are planned to be issued by TEMPO coming next year. We launched TEMPO in April of 2023. First light was in August of 2023, and the first public products were released in late May. We also recently launched in February 2024 PACE. PACE is an amazing ocean color instrument, but also thanks to its multi-angle polarimeter, it's able to measure the particle sizes and compositions of atmospheric aerosols globally. So we're now, we have first light from PACE. Public products are coming soon, so we're very excited about that. As well as Maya. Maya is the multi-angle imager for aerosols. Maya is a satellite being developed by the NASA Jet Propulsion Laboratory in Pasadena, California, and it represents a sentinel partnership between NASA and epidemiologists on a satellite mission. Maya is a targetable satellite in low Earth orbit. It will be targeting megacities across the globe and measuring different types of PM particle types, sizes, concentrations, and geolocation of those aerosols. These megacities have been targeted because with our partners in the epidemiological community, these cities have cohort health studies ongoing. So working with the epidemiologists and health organizations, we're going to take the PM data from Maya and help assess linkages between particulate matter types and adverse health outcomes. Maya is in cooperation with the Italian Space Agency, and we expect it to launch in mid-2025. And lastly, we have some funding opportunities out on the street through NASA's solicitation vehicle known as ROSES. I just wanted to point it out that we have 2 health solicitations from my program currently being open for proposals. One is due on August 6, 2024, and one for our collaborative health and air quality applied sciences team is due next week. So if you want more information on that, please visit the NASA Inspires website. And with that, I'll stop there. If you would like more information, not only on the Health and Air Quality Applications Program at NASA, but all of Earth Action, please visit our website at appliedsciences.nasa.gov.
Thank you so much, John. And for those who are interested, there are many great links in the chat that Helena put based on some of the stuff that John was talking about. So feel free to go into the chat and find them. All right, we're going to move to our next speaker. Our next speaker is Barry Baker. And Barry, feel free to start sharing your slide. Barry will talk about overview of NOAA's dust predictions from high resolution regional to global seasonal to sub-seasonal.
Everyone can see my screen?
We can see your screen and we can hear you loud and clear.
So yeah, I'm going to be talking about NOAA's operational forecasts. And mainly in this, I'm going to be talking about most of the Alarian models that we have. But yeah, so let's just go ahead and start. So just an overview. Right now, there's essentially three dust forecasts that are put out by NOAA, at least the NOAA National Weather Service, namely the Global Ensemble Forecast System with aerosols, as well as the National Air Quality Forecast capability. We also are adding in 2 additional systems. One is the Rapid Refresh Forecast System with smoke and dust. This is currently in prototype phase and hopefully will be implemented later this year or early next year. And then the next one is the seasonal forecast system to provide forecasts out 1 to 2 years. And so NOAA is currently undergoing a massive restructuring of its forecast models. Namely, right now we have currently 21 independent standalone systems, and we're trying to reduce this down so that these systems are easier to maintain and model, and things are pretty much more uniform throughout all of these systems. And so we're doing this through the Unified Forecast System. And so if you look, there are basically 3 areas or 4 areas that dust is really going to be an integral role here, and that's in the medium range to subseasonal forecast to the seasonal forecasting, as well as the short range regional high resolution and air quality models. And there likely will be more throughout this, particularly maybe in hurricanes eventually, but that system's honestly really expensive to run already. So that might be a bigger ask. And so this is just a different way to look at this. And so on the left, going up and down, we have all of our applications. And on the right, I've basically highlighted in yellow where dust is going to become a higher role within NOAA's forecasting systems. And so, basically, as you can see, this is getting more and more attention from NOAA's National Weather Service and their research community. So it's good news for us because it means that we get more visibility, not just within the National Weather Service, but as a nation and for the world. I think these forecasts are critical. So I just wanted to highlight the National Air Quality Forecast capability. This is the United States Air Quality Forecast. We've just implemented a new version of their air quality model, going from what was before the blue CONUS map to the red domain that's covering all of North America. So we've greatly expanded our domain. This is a 13-kilometer simulation, full chemical speciation, and includes wind-blown dust. And we've recently just put a lot of our historical data on Amazon Web Servers, so it's available. Historical data is available to the public. I don't want to go into necessarily all of these details, but all of NOAA's operational models for dust forecasting is actually all using the same dust scheme now that was originally created by Daniel Tong. And I've kind of adopted that and spread it across all of our applications now. And so the next one that should be implemented later this year is the Rapid Refresh Forecast System. This is a high resolution 3-kilometer domain covering all of North America. It's an hourly coupled deterministic system that is going to provide 18-hour forecasts. And then 4 times a day, it will provide a 60-hour forecast. In this, we are including 2 bins for dust, one fine mode and one coarse mode. It does not include anthropogenics and stuff, and so it might be a little hard to compare outside of large events for dust. But I am showing one example here. This was a dust storm in February earlier this year, or last year, sorry. Where dust came up through the Chihuahuan Desert and basically plowed through Texas and New Mexico, and this one actually ended up spreading all the way to the East Coast. And just a quick little example of us capturing this event. We actually did really well on this event, which doesn't always happen when comparing to point monitors. But all of this data is available, again, on AWS. All of the prototype data is already out there. And then we also have the Global Ensemble Forecast System. This is a global 25-kilometer system. It has 4 cycles per day. Right now, it forecasts out 5 days. It's based on a version of Go-Kart and is coupled to the GFS forecast model. And in this, we have 5 bins for dust. And so we've been working on this. This is what's currently operational right now. It's available through Amazon as well as the NOAA Nomad system. And this is just an example. This is for last year, actually during the early part of that dust event in February. I think this is February 2020, if I'm not mistaken. So the system before was NGAC, and what we're doing is we're showing the correlation coefficients between the model and AeroNet observations. And what we can see is that this new newer GEF system, is really a very large improvement over the old NGAC system. And you can also see this when comparing to dust storms, at individual points. And so, even comparing to ensemble products like ICAP and things like that, we do a really good job. And the system currently does not have any data assimilation, so it's just a free chemical run, but it is still performing very well. We're actually quite proud of that. So the next thing that we've been working on is to include forecast of aerosols into all ensemble members of GEFs. Currently, right now, it's only in one ensemble member. And so this will give us ensemble forecast for 35 days, so seasonal to sub-seasonal timescales. That is a 6-way coupled model. And being able to forecast out that far will give us advanced warning, obviously. And the next thing that we're going to be working on is the seasonal forecast system. This is going to be NOAA's replacement for the climate forecast system that they currently have. So all of the climate projections that NOAA puts out is done with this modeling system. And so for the first time, aerosols will be included into that system. And that means dust will be included. And so just to give a little bit more overview here, there's lots of updates here, but essentially the largest update besides updates to the dust model itself is we're increasing from 64 layers to 127 layers. And so, just an overview, we have 4 systems that are going to be going into operations in the next year or two, or are already in operations. And this includes the National Air Quality Forecast System. We've been doing this for over 20 years now. And the new system that was just implemented this spring is the UFS-based system. It's a 13-kilometer over North America, full chemical and 72-hour forecast. The Global Ensemble Forecast System is the global forecast system, and it has right now it is currently a 5-day forecast at approximately a 25-kilometer resolution. RFS is the next generation version of HER, and it will be 18-hour forecasts, except for every 6 hours there'll be a 60-hour forecast. And for the first time, this system will include dust over all of these domains. And then the next versions of GEFs should be a 31-member ensemble, as well as the seasonal forecast system, which should be a 11-member ensemble. And so, you know, the take-home message here is that NOAA is right now continually expanding its role in dust forecasting, and you know, more than that, it's expanding its air composition forecasts. And so we're very excited. There's slated to be upgrades to all of NOAA's systems, including the GEPS version 13, the air quality model, RFS, and the replacement for their climate forecast system, the seasonal forecast system. So with that, I'll stop there and try to give some additional time to other people.
Thank you so much, Barry. Just a reminder, we will have a town hall with discussion at the end of our talks. But if you have a specific question to a speaker, you can send them to them directly in the chat, and hopefully they'll see it and they'll be able to respond. All right, we're moving on to Danielle Tong. Daniel will talk about updates on WMO sand and dust storm research, global dust ensemble reanalysis. Daniel, we can see your slides.
Great, thank you. Yeah, thank you, Barry, for the introduction on the dust modeling. This is more like a global effort, so it's contributed by many people from the Sand and Dust Storms Global Steering Committee and the 4 centers, and then also a group of reanalysis experts who is helping out with this global dust ensemble reanalysis. So I just want to walk you through from center to center when they are doing the latest research projects. In China, they're building a satellite-based PM machine inversion and trying to use multi-sensors and come up with data fusion product so that they want to have a global 5 kilometer. They are also trying to promote their median and long-term prediction up to 15 days. So it's like a sub-seasonal. And they are also building key technology on quantitative inversion for dust. This is, again, is a part of the Asian Center under the WMO project. So if I put the center chair's name there, if you are interested in any of the projects for each centers, feel free to drop me an email. I will be happy to connect you. So in Korea, they are trying to really work on the AI for dust forecasting. They applied this to the deep neural network to the KMA, which is the Korean Meteorological Agency, trying to do post-processing after their ADAM, which is their operational data forecast model. And then do post-processing, try to improve that. And they have shown some evidence. In Japan, they are implementing this stone coverage for dust source region, which they have found that this has been very useful for some deserts like Gobi. And in India, they just installed this Wolfram-based system, but they're also working with Sinam, which is the Finnish model, trying to build up their regional air quality forecasting, including dust forecasting, because India also got their own dust problem. Mongolia is a new source right now. You heard of the story. There's hundreds of people killed and animals killed by dust storms. So they are adapting 2 models. One is this ADAM model from Korea, and also working with Sinam. And Sinam in Kazakhstan, they're also working with Sinam. So this is a lot of new systems being set up in Asia right now, trying to address their dust storm problems there. So moving to the Gulf region, this Gulf Cooperation Council, or you can call it more like a Middle East. So they have several new projects just launched. One is to develop this long-term dust data set by running Wolfram for the past 30 years over North Africa and the Middle East at a 4.5 kilometer. This is a very ambitious project. And they are also trying to evaluate multiple satellite data, trying to do a comparison with most of these aerolats, but they have their own network set in the region, which is a very exciting because this is a region we do not have a lot of observation data set. And they are building this decadal aerosol products, mostly focused on aerosol optical depths and also microphysical properties from different sensors. They are looking into MISR, MODIS, VIRS, OMI, and Calypso. So I don't have time to dive into this project, but this should be shared. We can share the slides with you. And over Pan America, this is the updates from CMIH, which is the Caribbean Institute for Meteorology and Hydrology, who is hosting the Pan America Center. And they are updating the WolfCam-based system, which is trying to simulate the transport of dust from Africa to Central America. And then they're also providing a lot of field and technical support for their collaborators, such as they're installing Purple Air across the island, and they are helping University of Miami on the Rig Point site, which is a legacy site that's been used widely by the data community. Initially, it was set up by Jules Prospero, and then now it's Cassie Gaston is take care of that. So really a treasure for the community. And they're also working with Tropopose on some field measurements there. So Pan America Center also did this survey or sort of mapping for the data vulnerability. There's a large group of people, many of those are sitting in the audience. We try to identify what kinds of hazards or health and safety impacts data will have over the population. So this is it's an incomplete survey, but now WMO is trying to adopt this method, extended to the entire world, trying to come up with a map, such as something showing on the right. It's going to come out with a new book called WMO Guideline on sand and dust impact-based prediction. So I want to spend the last few minutes on a new initiative called Global Dust Reanalysis Ensemble. The idea of this ensemble is there are multiple products from different centers, different agencies provide their own dust prediction, and they don't necessarily agree with each other. Okay, and for end users, they want to know what is, what is the one number I can have, and what's the range of uncertainty. So that's the motivation of building this ensemble system. Basically, we try to build this community consensus on global dust budget. They're starting from 2003 to present, because 2003 is, remember, we have both MODIS sensors, and this is like most widely used observation to constrain the models. And we're also trying to develop a tailored sand and dust storm product for services, such as for health, for WHO. There are two phases of this project. The first one is we're going to choose a very few global data sets, and that's from NASA, ECMWF, NIL, which is a Naval Research Laboratory, and Finnish Meteorological Institute. That's the first one, phase one, which I will report some progress today. And the phase two, we are going to build a blended global and regional reanalysis data sets. So there are a lot of regional reanalysis projects can be ushered into this project. So this is what currently available from this project. We just came out with the first version of the global dust data sets. It's at, as I mentioned, it's based on 4 centers. There's CAMS, reanalysis from ECM and WF. And we have NASA Measure2, which is well-known. And Naval Research Lab has the Navy aerosol analysis and prediction system. And then Finnish Meteorological Institute, they have the system for integrated modeling and atmospheric composition. So this one, Sinam, is very unique in that it's a free run, so it does not have data simulation. And all the other three are using satellite data and others to concentrate. It's actually very interesting to compare the Sinam reanalysis and then other ones that using the observation. And we came up with 3 ensemble methods, 2 unweighted ones, ensemble mean, ensemble median. And also we are right now developing this weighted ensemble. The data is available from 2003 to 2022. We are continuing to generate data as they come in. And the resolution is 0.1 degree globally. as a daily, monthly, yearly temporal resolution. It can be reprojected by country, and only for the United States, we have county level data. And parameters including AOD, that's AOD, that's only AOD, it does not represent others. And that's the PM2.5, that's the PM10, and it's also standard deviation to represent the uncertainty. This is just some a snapshot of what you will be getting from between the ensemble mean and ensemble medians. And most of the time they agree with each other, especially for AOD. But if you look at the surface concentration, it's actually a huge difference. And we are doing some preliminary quality control, especially compared that to IRLAT globally. You can see that in the major dust source regions like Africa and Asia, those models actually agree with each other pretty well, regardless they are using data simulation or not. Okay, which is a surprise for us because we expect that models do not use data simulation will show a big difference from the ones that are using that. And then for the performance really vary region by region. It's doing better in Africa and Asia, less so in Europe, especially in Oceania. So this is something that we are looking into further. So if you are interested in to contribute anything to dust modeling, observation, or you want like to help do data analysis, we welcome you to send us emails. Thank you. I'll stop here.
Thank you so much, Daniel. We are going to move to a health part. So we have two exciting speakers, and our first speaker is going to be Morgan Goris, and Morgan will talk about the role of dust in exposure to valley fever. We
Great.
can see your slide, Morgan. The stage is yours.
Thank you so much, Karine. Happy Dust Day. Thanks for having me today. I'm going to be sharing what I've learned so far about the role of dust in exposure to valley fever, which is an infectious fungal disease. So we're all aware that dust can have devastating health impacts. There's numerous studies that show that both PM10 and PM2.5 have been linked to reduced lung function, asthma attacks, bronchitis, and even premature death. And then there's even more specific health impacts from dust, including silicosis, which is caused by inhaling large amounts of crystalline silica dust. Recently, it's been shown that Saharan dust exposure has been linked to bacterial meningitis in Western Africa. And all of this, along with what Tom shared about microplastics and such, really gets me thinking, what's riding on or along with dust? And so one of the other pathogens that we know is associated with dust is coccidioides, which causes valley fever. The formal name for valley fever, the disease, is coccidioidomycosis. It's caused by the fungus coccidioides. And people contract coccidioides, or people contract coccidioidomycosis when they breathe in fungal spores. They enter your lungs and initially can cause, well, about 40% of people actually develop symptoms, and symptoms start like the flu. So it causes symptoms like rash, fever, chills. And then if your body can't fight off the infection, that fungus can actually replicate in your lungs, make it outside your lungs into your bloodstream, and even become fatal. Valley fever does not spread from human to humans, so cases are a direct result from environmental exposure. And interestingly, the total number of cases in the United States has been increasing. If you look at a bar graph in the top right-hand corner, we've got reported valley fever cases in the US over recent years, showing a general increase, which has been an increased cause of concern. Back in the 1930s, when we really started learning about this disease, there were a lot of military recruits into the Central Valley of California for World War II training. We have now recognized that this is a highly endemic area for valley fever. And one of the original studies noted that there was an association between dust exposure and more valley fever cases. But even since then, quantitative assessments linking the relationship between dust and valley fever has been challenging. We have continued to learn more about the life cycle of coccidioides. So first, in step one, coccidioides grows in arid and semi-arid soils in North and South America. Its primary job in the environment is to decompose animal proteins. And so it grows and it's happy when there's a little bit of soil moisture available for it and animal proteins to decompose. And then if it becomes stressed, like from drought or lack of nutrients available, its mechanism for survival is to break apart from those height-full strands into tiny fungal spores that are 2 to 5 microns in length. Any type of soil disturbance, whether that's a high winds event or someone digging in the dirt, can cause those spores to become airborne. And that's when humans or another animal can breathe them in and get sick with valley fever. But one thing we still don't have a good understanding of is how does coccidioides actually travel in the air? When that height-full strand breaks apart into the spores, do the spores travel alone? It's thought that maybe some fragments of the hypoform on either side of the spore might act as wings. So essentially the fungal spore could just float on in the air. Or does the fungal spore actually maybe electrostatically attach itself to dust? And so is it riding along with dust? Understanding this mechanism for airborne transport will be really important for future risk assessments of exposure to valley fever. And we also don't have a great understanding of what scale of dust exposure really matters most. Is it highly localized dust where we are directly digging in the dirt and breathing it in? Is it ambient concentrations where coccidioides is, biologically trying to just move around and spread itself and we're being exposed? Or is it long-range transport events? So we have some evidence that all three of these scales might be important. For highly localized dust exposure, I'm talking on the order of about 1 to 100 meters here. We have several lines of evidence from valley fever outbreaks where people have been, contracted valley fever from soil disturbance attached to construction sites like solar farm installation, digging wildfire lines. There were just 3 new cases happening in Arizona in the US from recent wildfire back in May. Dust production from movie sets in California, military training exercises, and even archaeological digs, where one in Utah in Dinosaur National Monument left all 10 archaeologists infected with valley fever. But this is quite difficult to quantitatively incorporate into studies since it's such highly localized exposure. So the community still is working to quantitatively capture this in our work. So the story for ambient dust exposure gets a little hazier, where time series analyses generally find weak or even contradicting relationships between dust and valley fever cases. So in Arizona, our work has found positive relationships between PM10 and valley fever incidence in winter. In California, they found negative relationships between PM10 and incidence in summer and fall. And from some of my work in the plots on the right-hand side, showing the seasonal cycle of valley fever incidence in the San Joaquin Valley of California, where incidence is peaking in October. That's following the dry season. If we look at the second bar graph down, looking at precipitation. But then if we look at dust mass, I grabbed it from MERA 2 here, there's not really a strong signal that might suggest that increased dust is related to increased valley fever in fall. So when we're looking at relationships between PM10, PM2.5, and valley fever, we're wondering, is this approach too generalized since we don't account from where the dust actually originates? Or how do we really tease out the signal and the noise here? Then there's also support that long-range transports events might be important for exposure to coccidioides. Just so fascinating, there's been just a handful of wild marine mammals in Central California that have come up infected with valley fever. I think this is a pretty interesting line of evidence that exposure to coccidioides from long-range dust transport is highly likely since they are not on land in those endemic soils. And then dust storms are also a very likely source for exposure to coccidioides. One of the most famous anecdotal stories is the Great Bakersfield Dust Storm in 1977. The winds were absolutely ripping at 192 miles per hour, and they reported over 500 new cases of valley fever, which was higher than any previously reported year in California to date. And interestingly, most were reported in Northern California in non-endemic areas. So it's pretty clear to me that exposure from coccidioides from dust storms is highly likely, but some studies that have further tried to correlate dust storms to valley fever cases have found it hard to do so. And I think that might come down to the origin of the dust storm really matters. Is that dust storm traveling over an endemic area and potentially picking up those spores? So in conclusion, and looking at the road ahead, valley fever is just one example of potentially deadly health impact from dust and dust storms. Redefining the physical mechanism for airborne transport will really enable us to better model exposure to coccidioides and valley fever risk. Understanding how each scale of dust transport comes into exposure and risk is also very important, including the role of dust storms. And accounting for the origin of those dust events and dust storms is a great path forward. So thanks for having me today to share some work on valley fever and dust.
Thank you so much, Morgan. We're going to move to our last talk of today. And this talk is going to be by James Crook. And James is going to talk about dust storm and health overview. So James, feel free to share your slides. And just a reminder for everyone, we're going to have a panel discussion right at the end of this talk.
All right, thank you, Karine. My name is James Crooks, and I'm an associate professor of biostatistics and bioinformatics at National Jewish Health, which is a research hospital in Denver, Colorado. I'm also an epidemiologist at the Colorado School of Public Health. I'm going to be talking more broadly than the previous talk about dust storms and health. I'm going to talk about first, like why we know anything about health effects of dust, and sort of comparison with particulate matter sort of generally, then go through what we do know about dust and health effects, and then sort of point out some areas where the results are not necessarily super consistent or where we need new research and tools. So to start with, all right, so how do we know anything about, particulate pollution and health at all? Well, it sort of goes back to the middle of the 20th century, when in London and in Pittsburgh and in Los Angeles, you had these like thermal inversions where there was a lot of usually coal burning at homes or at factories, and you get a lot of coal dust buildup in the air, can't see your hand in front of your face kind of a situation. The hospitals would start seeing lots of people coming in for respiratory ailments and, or lots of additional mortality that was pretty clearly linked. So that generated the first research into health effects of this kind of particulate air pollution, really with the focus on this anthropogenic sources. And then that research then led to sort of more public interest, and public interest led to political pressure, and that led to more laws being passed and more regulation. But the initial health effects that we're focused on were really sort of this kind of anthropogenic PM in general, or PM10 maybe, and its effect on respiratory health. So COPD, asthma, emphysema exacerbations, lung cancer, kind of an analogy to smoking. As the regulations were established, you get better monitoring, you can do kind of larger and larger research projects. People started to realize that, like, okay, the health effects that we're seeing, maybe they're driven by the smaller particles that can get deeper into the lung and that are harder to just clear by coughing, sneezing, swallowing. And you're so deep in the lung that your immune system essentially has to take care of it. And so starting in the 90s, there was a lot of interest in PM2.5 because of how deep it could get in the lung. And the thing that really surprised a lot of epidemiologists back then was that while they saw some links to respiratory endpoints, it was really the cardiovascular ones that were even more impressive. And they were trying to figure out why, and it has to do with sort of inflammation in the lung, and that inflammation can kind of spread to the rest of the body. And it turns out that this link between PM2.5 and cardiovascular disease is by far the most important link between any air pollutant and any health outcome, probably between any environmental exposure generally and any health outcome at a population level in terms of number of people who die. And so if you look at the global burden of diseases study, air pollution is usually like the number 4, particulate air pollution is usually like the number 4 risk factor for mortality, killing, responsible for something like 7 million deaths a year globally. But again, research doesn't stand still. And ever since then, as people have come to understand the role that inflammation plays, inflammation plays a role in lots of other diseases, not just cardiovascular related diseases. So they found links between particulate air pollution and lots and lots of other diseases, lots of organ systems, all kinds of stuff, not just respiratory and cardiovascular, birth outcomes, neurological disorders, metabolic disorders like obesity, kidney disorders, and the list kind of keeps growing over time. There's also been an explosion of research on PM2.5 around the world. So it's not now just focused on the US, Europe. Now we have lots of research in China, lots of research in the Middle East, and Southeast Asia. So we know a ton about the effects of particulate matter, especially fine particulate matter, on health. So how does dust fit into all this? Well, one thing to notice about that previous slide is that the reason we know so much is because there was this underlying positive reinforcement cycle between health effects research back in the mid-20th century led to laws and regulations. In order to implement those laws and regulations, there had to be models developed and monitoring networks established that led to more health effects research that led to better regulation. So that, there's this positive reinforcement cycle and the science gets better and better and better over time. Dust really, or non-anthropogenic PM really can't access this cycle because regulators don't want to regulate non-anthropogenic sources. It's much harder to justify that. And they don't, lawmakers aren't rushing out to regulate them. So in order to do research on non-anthropogenic PM, they have to piggyback on monitoring, remote sensing, physiological knowledge, epidemiology methods, et cetera, developed for PM generally that are not specific to dust. And that, at least that data is there, but it's also not quite the perfect fit for doing dust-related health research. Now, one thing that, health effects research on dust can start a virtuous cycle, but it doesn't then include health later on quite so obviously. So health effects research can lead to, justification for developing forecasts like Daniel Tong was talking about. Better forecasting can help justify better monitoring or better remote sensing, data products from remote sensing that are really focused on dust. The more data you have like that, you can justify more forecasting and better climatology research, which then feeds back into the monitoring and remote sensing. After the first stage, it's sort of hard to see how health effects research kind of fits into that. Hopefully it does somewhere, but it's not quite so obvious as it is with PM in general. I would also say, at least in the US, the focus on PM 2.5 and the fact that we found so many health effects based on it has led to the person searching for their keys under the lamppost kind of a problem, where because we know health effects are there, we keep studying them more, and attention has really drifted away from the larger PM in terms of epidemiology research around PM. So there was actually like an 18-year gap in publication of any research in the US at all on coarse PM or dust between 1998 and 2016. There might have been like one small exception, but like essentially no research on it whatsoever. Now it's sort of kicking back up. There's more interest in dust now, but totally dwarfed by the interest on anthropogenic PM as well as wildfire smoke. Okay, so what do we actually know? This sort of check table is based on the very cursory Google Scholar search that I did yesterday First 3 pages of Google Scholars, I basically put a check mark anytime I found any paper anywhere in the world that found a link. So the columns here are different kinds of administrative data sets that we can look at: mortality, ICU admissions, hospitalizations, ER visits. And the rows here are different causes of whatever that endpoint was. So respiratory, cardiovascular, and then within each category, there's sort of more specific subcategories. And so this very non-complete survey, we find lots of checkboxes, which gives us confidence that dust storms are in fact affecting health. Now, there's also evidence for dust storms and birth outcomes, childhood outcomes like childhood development, as well as kind of less severe clinical outcomes like inhaler usage and stuff like that. So this is not a complete table in that way either. The issue is, even where we find a check mark here, there may be other papers that didn't find one. So there's actually a fair amount of heterogeneity depending on countries being studied, what time periods being studied, what dust metric is being used to assign the health effect. So things are pretty messy right now. We also find that the papers find different magnitudes of health effects sometimes. They may find a different lagged effect. So if you have a heart attack because of dust exposure, is it happening that day? Is it happening 2 days later? So different ways of accounting for that find kind of different results. We also find, in order to really sort of nail down that dust is affecting health, we really need to complement the population and clinical level research with in vitro and in vivo studies where you're exposing lab mice or exposing, tissue cultures to dust and seeing what happens. We also get differences in sort of underlying statistical models used to ascertain whether there's a dust effect at all. That can be a good thing, because if you're seeing a health effect under many different statistical models, that gives you confidence that it's real. But if you're seeing a health effect with some models and not with others, then it sort of makes things more confusing. Okay, now there was this group, maybe some of you were a part of it, that did a scoping review on desert dust and sandstorms and human health. I believe it's for the World Health Organization. Just came out a couple of years ago. They did find a fair amount of consistency for respiratory and cardiovascular mortality and morbidity. Morbidity meaning like hospitalizations and ICU visits. So they did find some consistency. I wouldn't say it's obviously not perfect. It will never be perfect. More interestingly is, like, within the broad category of respiratory or cardiovascular, what about the specific causes within them? There is pretty good evidence that dust storms do have health effects. Like, we can be pretty confident about that. But there's still a lot of inconsistencies around the subtleties, a lot of heterogeneity. Some of it's, I'm going to go through some potential reasons. Dust in different parts of the world can have different underlying toxicity, different microbial content, maybe different other stuff piggybacking on the dust, different physical properties based on the mineralogy. Also, when we're doing dust epidemiology, we tend to mean different things in different parts of the world. So some places you really focus on the storm, like, are you impacted by the storm, that localized extreme event? In other parts of the world, you're really focused on the long-term dust transport or long-range dust transport. So you're not really seeing the storm itself, you're just seeing high dust days. There's also, some differences about how you even characterize dust in the first place, even once you decide which of those to use. Is it PM10? Is it coarse PM? Is it some sort of modeled or reanalysis product? Like Daniel mentioned, is it, you characterize it using AOD or visibility or meteorological observations, some combination of the above? Do you then leave it as a continuous number, or dichotomize it somehow, be like, values above this number are considered a dust storm and values below are not? All of this leads to a lot of difficulty comparing health effect studies across different areas and different research groups. So what actually would make a good dust exposure metric for epidemiology studies. First, you need it to be accurate. That is, we need to understand what we mean by dust. But also, once we figure that out, if we have PM being part of that dust characterization, we really needed to match the ground monitor observations. If we don't have that, the epidemiology community does not take it seriously. So we really need to be able to, match the ground observations as closely as we can. We need data set that's spatially complete over a large domain, like an entire country. We need complete temporal coverage over a long time period, usually like 10 plus years, to really be usable. Otherwise, lots of other confounding factors, are kind of overtake any kind of health effect that you're seeing from dust. So you need a long time series to have power to sort of factor out those other things. It'd be great to have really high spatial resolution. The standard in particulate matter research is 1 kilometer. We're not really anywhere close to that with dust, as far as I know, especially if you're looking at, national level data sets, but that's really what we'd like to have. And then daily or better temporal resolution. That one's probably not too hard to get, but daily or better temporal resolution, and then this really high level of accuracy is probably pretty hard to do. And I don't know that any product does that right now. I know we're, Daniel and I and a bunch of other people are sort of working on, working to get things closer to, this ideal. This is the goal. And that's it. Thank you so much, Karine.
Thank you so much, James. I'm going to ask all our speakers to turn on their cameras. And first of all, I want to thank each one of you for being here today for the very interesting talks. Keep us with a lot of open questions of things we still don't know. And I'm going to move it to Andrea and Scott, but remember to come back to me at the end for some announcement. Andrea and Scott, the stage is yours.
Yeah, thank you,
Okay,
Karine.
Corinne. Go ahead, Scott. Thanks, Corinne.
I
Thanks.
just want to quickly recap the talks. Started out with some of the challenges that wind erosion and dust posed by Tom Gill, and that was followed by Kevin Perry looking at dust emissions off of dry lake beds. And there are many dry lake beds around the world, so this is a global issue. That was followed very quickly by John Haynes talking to us about tools that NASA has to offer us to look at this. Excuse me, before that it was Daniel Buchazo talking about South American dust sources and research activities down there. I thought it was kind of interesting that you finished up with the studies on the transport of herbicides and herbicide daughter products. So I know that was a big part of your activity down there for a decade or better. And then we heard from John with the tools that NASA has to offer. And that was followed pretty quickly by Barry talking about some of the NOAA models, and Daniel with WMO's new emphasis on dust and ways of looking at it. And then we got back down to the health effects again with Morgan, and with James. So with that, if you have any questions, please put it in the chat box. And that way, Andrea and I can see those questions. We can read those questions aloud to the various speakers and get some responses from them. And hopefully we'll get a discussion going here where we don't have to necessarily go to the chat box, that we just kind of get discussing and people adding on little snippets of information to help the whole group. So
There are about 3 questions already in the chat, but if
Okay.
persons also want to unmute, what I'm going to do, I'm going to go ahead and start fielding read those questions that were already dropped into the chat room. And then if persons want to drop more questions in the chat or unmute, which would be great, so we can get an even more robust discussion, we can do that. So I'm going to start with the questions that were already posted. The first question is, I am part of a project in Pinal County, Arizona, USA, exploring soil stabilization options to control dust from fallowed farms. We are having issues with our dust monitors, which aren't holding up under high heat. What is a good heat tolerant, or what are good heat tolerant monitoring options? So good heat tolerant monitoring options for
I thought this would
Pinal
be a question
County.
for Daniel. Possibly.
We have
For
two Daniel.
Daniel, okay, great, thanks, good. I wanted to ask the, yeah, if you know who you specifically want to address the question to, you can also put that in the chat, or you can unmute and say, thank you.
Well, I can take a first shot, but I'm no expert on this. Are you talking about low cost sensors, or this is a regulatory monitor?
It's not regulatory. We're doing scientific research.
Okay, so it's no cost. Yeah, I don't know. Is any good ones on this? I wonder, is anybody in the audience would like to offer some thoughts on this specific topic?
I know I've got a project under NASA right now. We're starting to look at the calibration constants on the purple air with changes in temperature and humidities. But I don't know what the upper end of temperature is on those particular sensors. You know, it's not so much oftentimes the maximum temperatures that electronics experience as much as it is the range of temperatures as things expand and contract with changes in temperature. So the jury's probably still out on that one, and probably the best solution for you would be to go back to good old glass fiber filters and aspirated samplers. And that's not going to give you real-time results, but it will give you results, and probably much more reliable than electronics in a changing environment.
Maybe if I
That's
could just add, from the South Coast AQMD, we've looked at this quite a bit. So we have this air quality performance evaluation center at our agency. So purple airs do not measure PM10 well at all. They don't measure coarse well at all, sort of almost a random number generator. We have had a bit of success using an ES642, which is sort of a medium cost sensor for measuring PM10. However, it still has to be calibrated. So we're in the process of deploying two of them, one co-located with a regulatory monitor and one in an unmonitored location in the Coachella Valley, which has similar temperatures to the Arizona desert.
So if you want to follow what model?
ES642. And if anybody wants to follow up with me, we can let you know how those results are going. My email is sepstein@aqmd.gov. I can put it in the chat. Thanks.
Okay, and the next question is, and this one was also from B. Scott, for another question. I would like to look at historical satellite data to identify dust storm formation locations and tracks that are local to Arizona. What's the most appropriate resource? And probably the satellite data, the person to ask that of would be John Haynes.
Be John, yeah.
Well, can you hear me?
I hear you.
Okay, great. I'm going to start off, but I'm actually going to then turn it over to Daniel, because he's actually done work with NASA and NOAA and state agencies in Arizona on this topic. So he's the subject matter expert. But I will say, in general, when we're talking about this data, and I put some links in the chat for this, to help members of our community, stakeholders, and end users help guide the huge portal of earthdata.nasa.gov. We have data pathfinders that help you kind of zero in on which data sets are going to be most appropriate for the work you're looking for and where to find them. So I posted the NASA Air Quality Data Pathfinder into the chat, as well as our NASA Health and Air Quality Applied Sciences team, which is a team of 14 PIs who work collaboratively together on environmental health and air quality issues, led by Dr. Tracy Holloway of the University of Wisconsin. Daniel Tong is also a member of HACAST. If you go to their website, they have a lot of tools and resources available to help you get started on where and what type of data is going to be more useful to you and where to find it, as well as a community forum where you can directly ask members of the HACAST team if you have issues or questions. So those are the best resources to start the journey. But Bing Daniels worked directly on projects in Arizona and New Mexico with dust, with satellite data. I'm going to turn it over to him.
Thank you, John. I have to say, this is very difficult to actually look at the dust storms over Arizona, because in this region we find is particularly difficult to detect from space. That's because they frequently have a cloud, and then also the dust occurred after sunset, or even late in the day. It's not ideal for the satellite sensors to look into that. So you can look into, there are generally two products. You can look at the column density or also optical depths. Paul Gineau developed a data set called dust optical depths, DOD, that is using MODIS, use AOD, and then also some other parameters trying to combine it to detect the dust. That's one data set. Another one, probably more useful if you want to just look at it, is using the geostationary, like the GOES satellite. I'm going to drop a website developed by NOAA in the chat. They really integrate multiple satellites, the geostationary satellite and then polar orbiting satellites, and also ground data together. So sometimes you can take a look of that. On the source, I think I wonder, will Tom Gill be willing to share some ideas, identify dust sources from satellite?
Yeah, and in fact, I just responded specifically to the questioner, but you make a very good point, Daniel, kind of pro and con. Historically, looking at the long-term record of dust sources, there's been a tremendous amount of work done by looking at the historical record of imagery from MODIS, Terra, and Aqua to identify dust point sources on the landscape to within potentially less than half a kilometer resolution. And it would still be worthwhile to try to do that for Arizona. There's dozens of publications that have applied that for other places. The problem is, as you mentioned, Daniel, in Arizona, a lot of the dust storms are these haboobs that come with convective storms. And in Arizona, especially compared to maybe some of the other regions, you can't see the dust sources very well from satellite because they're underneath the clouds. You might have better luck with, for example, MODIS and other sensors in terms of trying to pinpoint dust source areas from the springtime dust sources that come with synoptic dry fronts. So it's definitely going to be a challenge in a place like Arizona.
Another potential source can be the temple that both Tom and John mentioned earlier. But that one right now is focused on trace gases. So I'm very much like to see more also product come from temple, because it's a combination with high resolution and also high spatial resolution and high temporal resolution, and only focus.
I think
North America.
Daniel and I are both like really looking forward to when hopefully these types of aerosol data will be available from missions like Tempo, because it holds a tremendous amount of promise.
Yeah, I may add one more thing, is that the other mission, Maya, is very unique, that they are actually going to fly through a city and then look at the city from different angles. So that will give you actually a better chance as well compared to the other polar orbiting satellites. But unfortunately, Phoenix is not one of the primary target area. They have one LA, I believe. So that's too close. So both a few years ago, both James and I went to the Maya meeting. We tried to push for getting some dust cities as a secondary target area. So we will get at least some limited observation from Maya, so that I will be happy to keep this community informed if they decide to take one of our suggestions.
Okay, next question, Andrea. You want to read this one on the
Sure.
characters?
Yeah. Another question, I'm curious if there's any data on the characterization of dust particles from dry lake beds versus dry rivers.
Kevin, you want to tackle this one? You're muted.
I don't know the answer to that sort of thing because the spatial scale is really small. So I don't have any direct information that would help answer that.
I'm going to guess there'd be a lot more solubles in the dust from the dry lake bed than from the river itself, because the river is constantly flushing, whereas terminal lakes are an accumulation zone. Would you agree with that?
Yeah, I would, sort of thing, but a lot of it comes down to particle size distribution, and in the river deltas, it's going to be different than dry lake beds.
Yeah, I think the big difference would be in the soluble salts and the salts that occasionally puff up or effloresce to the surface and create what some people called salt storms from some of the dry lake beds. I mean, Kevin has certainly seen some of those, I'm sure, at the Great Salt Lake. We've seen them at a lot of other lakes. I would think, like Scott said, that the dry river beds would not have as much of the soluble salts. And I know there have been a few studies here and there of like the mineralogy and the chemistry of soils or sediments from different dust sources. You just have to pick around and find them. I'd say the biggest difference, though, would be for sure the salts.
And then just along those lines, Lake Powell, as it has been shrinking from lake status to river status, has immense amounts of silt that have accumulated that the river is basically cutting through, and that's an emerging dust source as well.
As is Lake Mead, I would have guessed. Next question is there any source of PM 2.5 data across Texas? And one of our participants said, you can probably try TCEQ, but somebody else was wondering if there was a source other than TCEQ. Anybody want to tackle that one? I don't, other than Guadalupe Peak, I don't think we even have any improved stations in the state of Texas.
There are several air now monitors there, but it's,
Okay.
For the size of Texas, it's few and far between.
And to tell you the truth, I haven't gotten on and taken a look at densities of purple air networks in Texas.
I can jump in on that. It's very low and don't use it for dust.
All right. Next question.
I think we had another satellite question, but I don't know if that was answered. Looking at historical satellite data to identify the storm formation location and tracks that are local to Arizona, what is the most appropriate resource? And I think the person had said John Haynes. They wanted to direct the question to John.
We did get a response for that.
Yeah, we've already been through that.
You did?
one.
Okay.
Yeah, we're
All right. I
quite a
wasn't sure
ways
if that
down,
was...
Andrea. I'll grab this one real quick. What's the best way to get the NOAA maps of dust storms in the Great Basin in recent years? Barry responded in the chat, but you want to tell us about it orally?
Yeah, so I might not be the best person for this, but there is the storm event database at NCDC that you can look that up. They'll have all of the warnings and things like that as a record there. And I put the link in the chat.
Okay. And I believe there are some efforts ongoing to improve that database and draw resources together to kind of a unified database. Is there anybody here that would like to address those efforts?
I can jump in quickly and just say, please don't use the dust storm database, or if you do, please use it with caution. And Danielle, Tom, and I have a paper describing why you should use it with caution. I can say that my group is currently working on creating database for the last 20 years for across the US. So stay tuned, and hopefully in a few years, we'll have information about dust storm and dust events from 2000 to 2020 across the US.
Okay, I'll go ahead and read the next question. It says, great talks by the speakers. I'm working on dust in Utah and am in need of wind speed and direction data. I'm currently looking at the NOAA database, and is a lot of information. Whoops, it just jumped. A lot of
information in that regard.
Yeah.
Can anyone advise on the particular way to get more specific data?
Yeah, I can handle that one sort of thing. I'll put it in the chat, but there's a database called MesoWest, which is a repository for all surface-based monitors in pretty much the US, but specifically the Western US. And I just put a link to that for Utah in the chat.
Somebody else mentioned Weather Underground. They said they're amateur weather stations, but a high degree of spatial coverage.
Don't see any new questions. Okay, go ahead,
I have a
Scott.
question for Kevin, and that is from the dust that's emanating off Salt Lake. About what percentage of that is soluble, and how does that compare with what you know of other dry terminal lakes in the American West?
So a lot of people think of Great Salt Lake as looking like Bonneville salt flats. And that's not the case. I mean, it's basically your typical sandy soil with high evaporite mineral concentrations. So in terms of an exact percentage, I'd have to go back and look at that sort of thing, but it's high. It really is relative to other dust sources that don't come from these saline lakes. But in terms of trace metals, arsenic is one of the ones that is in there at concentrations higher than Owens Lake, but many of the saline lakes in the Western US have high arsenic concentrations as well, sort of thing. So.
I've got a question for John too. Are any of the satellite products looking at salts, or is it just primarily particulates that they're able to pick up? Did EMIT look at any of the soluble minerals?
Talking about salts in particular, I do not recall that being a particular product anywhere. someone else who's worked with satellite data as well may correct me, but I don't recall that. Now, there will be, when we have Maya, we will be getting information on particle type, size, and composition.
Okay. Well, folks, I don't see any other questions coming up. Let's go ahead and move on to closing and final announcements. We're about 14 minutes over, and I know some of the speakers said they needed to skedaddle a little bit early, so we'll go ahead and close out the panel discussion. I want to thank all the authors and participants in the panel discussion and the information they were able to provide. I hope it was useful for folks. And we'll go now into the announcements.
All right. Well, again, thank you for all the speakers who came today and for their very interesting talks. Thank you for Andrea and Scott for running the show today. The only announcement I will have is keep in mind, if you are not familiar with Dana, I just put our website in the chat. Make sure to register. We're going to start in September back again our webinars. We're having webinar every second Friday. And look at that website. You can find old webinars, and I might be looking for some of you. If you would like to volunteer to give a webinar this year, please reach out to me or put in the email for Dana. And we need new speakers. We would like to go for other places across the US and also to South America. So please volunteer to give a webinar, or you might get an email from me and Jenny and Ling about it. And thank you all for coming today. Happy Dust Day. We hope we'll see you soon in our next Dust meeting. And big thanks to everyone who joined us today as an audience. Thank you so much. Happy Friday.
Bye, guys.
Dust Day, everyone.